Some things we need to know about acids and bases. Common acids which we work with in a school laboratory are sulfuric acid, nitric acid, hydrochloric acid, ethanoic acid, carbonic acid. Here are their formulae. All the formulae have one element in common. All acids contain hydrogen atoms. Acids are sour-tasting substances. Vinegar sprinkled on chips gives them a deliciously sour taste. Vinegar contains ethanoic acid. On the other hand, bases taste bitter. Have you ever tasted soap or sodium bicarbonate? The bases that we use in a school laboratory are sodium hydroxide, potassium hydroxide, calcium hydroxide, magnesium hydroxide, sodium carbonate, ammonia, and ammonium hydroxide. It is tempting to say that all these substances have a hydroxide ion in them, but then ammonia and sodium carbonate don't fit in. Now, all we can say is that bases neutralize the effect of acids. Acids react with bases to form their salts and water. The pH of acids is lower than 7. The pH of bases is higher than 7. Solutions with a pH of 7 are neutral. They are neither acidic nor basic. Fizzy drinks have a pH of about 2. Milk is about pH 6. Baking powder about pH 8. And detergents pH 12. Indicators such as the litmus paper change color in an acid and a base. Litmus paper turns red in an acid and blue in a base. If you put the blue paper back into the acid, it goes red again. Litmus is an indicator. It changes color in an acid and a base. The common indicators that we will use in the school laboratory are litmus, methyl orange, bromothiamyl blue, and phenolphthalein. Acids neutralize bases, and bases neutralize acids. Neutralization reactions are complete when there are equivalent amounts of acid and base present. Sometimes we suffer from acid indigestion, so we chew an antacid tablet to neutralize the effects of too much acid in our stomachs. The tablet often contains calcium carbonate, which is a base. It reacts with gastric acid to regulate the pH. Dropping these two tablets into acid, colored with bromothiamyl blue indicator, will give you an idea of what is happening inside your stomach when you take an antacid. Milk of magnesia is also used to soothe indigestion. Milk of magnesia contains a suspension of magnesium hydroxide, which reacts with the acid to form magnesium chloride and water. This time there is no gas given off during the reaction, and you can see that the acid was neutralized. The bromothiamyl blue changes from yellow to green. Concentrated acids contain many moles of the acid per unit volume of solution. Dilute acids have fewer moles of acid per unit volume. Dilute acids are prepared by adding a small amount of the concentrated acid to distilled water. Remember that we always add concentrated acid to water and not water to a concentrated acid. This is because the concentrated acid becomes very hot as it ionizes with the water, and this can lead to steam with a spray of the concentrated acid in it being given off. Bases which dissolve in water are called alkalis. Example, sodium hydroxide, potassium hydroxide, ammonium hydroxide, calcium hydroxide, sodium carbonate, sodium bicarbonate. Metal carbonates are also basic. Most metal carbonates don't dissolve in water. They are bases. They are not alkalis because these substances don't dissolve in water. Now, if we add a small amount to dilute hydrochloric acid and swirl the test tube carefully, you will see bubbles of gas being given off. If we trap this gas and test it by bubbling the gas through clear lime water, the lime water turns milky. Metal carbonates give off carbon dioxide when they react with acid. Metal carbonates react with acids in a gas-forming reaction. The gas that's given off turns clear lime water milky. Acids release carbon dioxide from metal carbonates. You may remember another gas-forming reaction which happens when an acid reacts with the reactive metal. When granules of zinc are added to dilute hydrochloric acid, bubbles of gas are given off. Trap the gas by placing your thumb over the mouth of the test tube. Ask a friend to light a splint and bring the flame close to the test tube. Release your thumb so the gas can ignite in the flame. Did you hear that popping sound? The gas is hydrogen. Hydrogen explodes when it combines with oxygen. Hydrochloric acid releases hydrogen gas when it reacts with zinc. Although this is a characteristic property of acids, this reaction is not an acid-base reaction. It involves a transfer of electrons from zinc to the hydrogen ion. The hydrogen ions each accept an electron to form a hydrogen atom, and then they join up to make a molecule of hydrogen gas. This reaction is an oxidation, reduction reaction, a redox reaction. We discuss redox reactions in another series of animations. The acid-base reactions which we study all involve the formation of a salt and water. We are now ready to move on to studying acid-base reactions in greater detail. The first lesson deals with theories of acids and bases.